Hello, my name is Marianne. I'm the Technical Director at People Powered Retrofit. We're a community benefit organisation that aims to support householders and the industry more widely to develop more and better retrofit. And I've been asked here today to just say a little bit about some retrofit principles, so the things that you need to think about when approaching any retrofit project to make sure that you enable the best outcomes possible, really. I think one of the issues with retrofit is that there's lots and lots of questions and it can be quite complicated. So one of the big ones at the moment is whether or not we should worry about fabric and just fit as many heat pumps as possible, or do lots of deep retrofit first, what we should do about ventilation and what the best ventilation systems might be, what kind of benchmarking we should use, whether EPCs are useful or whether there are other targets that we should be aiming for in terms of the impact that we have. And also what you can do on kind of limited funds or with limited amounts of disruption and limited headspace and capacity. So it's kind of what's possible within the parameters that we have. I would always argue that the best thing to do is acknowledge that this is complicated and understand that all of these questions can only really be answered with another set of questions, which are about understanding your aims and your priorities. Ultimately, it all comes down to what is it that you're actually trying to achieve. And then by understanding that as well as you can, you're able to answer some of those other questions, hopefully, and understand where your efforts should go, what you should be prioritizing, what you should emphasize. So I think a really key thing in this is to understand what your retrofit priorities are. So is it purely about carbon emissions reductions? Is that all you're concerned about? Is it about fuel poverty and fuel bill reductions? Is that a different angle on things that you are most focused on? Or is it about the comfort and the health of the occupants and also possibly of the buildings? The other things listed there, there's lots to be thinking about. There's lots of things to take into account. I think what you need to understand from that is that things like decarbonisation have technologies and approaches and methodologies that go best with them versus things like comfort and health and fuel poverty, which may have some overlapping approaches that work well and things that align, but they're not actually the same thing. So if you want to decarbonize a home, one of the best things you could possibly do is get rid of fossil fuels from its heating system and electrify the heating. But that isn't necessarily going to do a huge amount, at the moment, at least, with the way that energy prices are structured, for fuel poverty or reducing people's fuel bills. It's also not necessarily going to make much of a difference to people's comfort and health, depending on the state of the existing building and if there are issues with large drafts or problems with damp and all those kind of things. So each of these aspects of what can be achieved with retrofit requires a different approach, and understanding what your focus is and which of those that you're most driven to achieve, which sometimes that might be about the needs of the people in the house. No doubt, I mean, that's what it should always be about, really. But no doubt it will also be about how much money you have, what the requirements of funders are, all of these other things go into it. But being clear about your aims at the outset will really help you make decisions further down the project. Because ultimately, it's the retrofit project brief that's the really key document. It's going to help you understand what you're focusing on, what you can safely exclude, what things might be distractions. And that brief is all about establishing intended outcomes as set out in PAS 2035, the standard that a lot of us are working to. It's not about, you know, whether or not you've fitted a specific technology. It's not about bells and whistles. It's about what are the outcomes that you're trying to achieve, and understanding that is really key to any successful retrofit project. I think once you've understood that, there are some key principles that it's useful to keep in mind when you're thinking about retrofit. And this applies to any building, and I think it applies also whether your focus is decarbonisation or fuel poverty or comfort or something else. The first of these, I would say, is always to practice responsible retrofit. So always try and understand the context. What's the existing construction you're dealing with? Whether it's solid walls or cavity walls, what's the condition of that? So are there existing problems that need to be addressed, whether they be structural or damp, or things like failed cavity wall insulation or failing roof timbers? All of those things need to be understood before you start making plans as to how you're going to change that particular house or that group of houses. Alongside that, you really need to understand how the building is lived in and residents' needs and wishes. So it's no good designing something that might be a perfect technical solution, but it doesn't work for the people who are living in it. Does it meet their needs? Going wider than that, you also then need to understand things like flood risk and radon risk, and whether there's a risk of subsidence either at the moment or due to changes that are going to come with climate change, and also overheating, which feels a little bit counterintuitive sometimes, but we're getting problems with too much heat in the summer as much as too little heat in the winter. Local energy and grid constraints, planning constraints, heritage, all of that. You have to understand the whole thing together to understand what your constraints are. So once you've decided what your outcomes, what are the constraints on those outcomes? And then really key alongside that is each of these things is interplays with each of the others. And every house really is a system. It functions as a system. We've got, in this instance, this illustration, this is focused on moisture in the building, but you can see that moisture in the building isn't just one thing. It's a range of different systems that are to do with the technologies in the building. People have got washing machines, dryers, cooking, all that kind of thing. People in the building creating moisture, but also the fabric of the building, the ventilation system, whether people have got dehumidifiers running, all that kind of stuff all goes together and they all interact. It's not about simple kits of parts, it's about a systemic approach. I think a second really key principle is that repairs and maintenance really need to, if not come first, at least be considered first. So repairing leaking gutters, replacing window seals, repointing walls, all of that stuff needs to be done and either done up front or incorporated in your retrofit plans. Because otherwise, well, in the first instance, just doing those things will have an impact on the energy performance of a home and comfort and health in the home and health and well-being of occupants. But also it's the big risk thing in that if you add retrofit measures, as happened in the photograph here, but if you add retrofit measures to somewhere where, say, the gutters are already failing, or there's already a problem with condensation in the roof space, you're just going to create or exacerbate create new problems or exacerbate existing problems. The other thing that we think about, I know a lot of people talk about fabric first, and I have done myself quite often, but I think it's something that can be potentially misconstrued, or it's ended up being a bit of a crazy debate between fabric first and heat pump only, which is, polarized debates don't necessarily help anyone. What I would always suggest is that people balance fabric improvements and heat decarbonisation. So you're making the fabric improvements that make sense, that will make a difference to heating bills, to the health of the building, to the health of and the comfort of the people who live there, but also acknowledging that doing that well can be really tricky and quite disruptive. And it's not always possible, either because your budget is too limited to do something really well, or because, if you're going to tackle all those thermal bridges, or there might be heritage constraints, restrictions, or planning restrictions, or you're too close to the highway, all of these things. So rather than doing a kind of half a job, I guess, you try and do what it is possible to do really, really well, and then you balance that with heat decarbonisation, which usually means electrified heat and often means heat pumps. Yeah, just another illustration there of how disruptive and messy some fabric works can be. That's getting external wall insulation done and re-roofing. But even with all of that work, it can make a big difference to the comfort and the well-being of occupants, the health of the building, protect the building from the weather, all of that work. But it generally makes a lesser contribution to decarbonisation and overall reductions in energy use. It can be helpful to the grid in that it reduces peak demand, but the big decrease in carbon emissions and total energy demand across our housing stock is going to come from replacing fossil gas and other fossil fueled heating systems that burn things with electrified heat and heat pumps. That graph there is from the Letty Retrofit Guide, which I'd really recommend people have a look at. Sets out a lot of the context of retrofit in a really useful, accessible way with lots of quite good graphics. Because I think what you're ultimately saying is that at an individual house level, whilst at national level, policy and funding should really be driving both decarbonisation, so we should be about getting rid of fossil gas boilers and oil boilers and that kind of thing, and addressing fuel poverty and making sure that people can actually afford to heat their homes to a healthy level. But when you're looking at an individual house or an individual project, we'd always advocate understanding first. So that's understanding the condition and the context of the building and the needs of the residents to arrive at a plan that works for them and works for that building within all of those other constraints, so that it's very, very context dependent and about what those residents or that landlord or that property is most suited to. And just to say, so that this is an image of a project that I was involved in Leeds, where we did do full deep retrofit of some very, very drafty, very not well performing wimpy no fines houses. And there, the full deep retrofit works made a lot of sense because they were tackling fuel poverty, but it was also a part of a decarbonisation programme. So they also included heat pumps where they could. And then the solar panels on the roof obviously do something for the decarbonisation of electricity in the grid, but also massively help reduce people's fuel bills if they're in all the time during the day, and their heat pump can then be running off the solar PV in the spring and the autumn at least, and doing hot water in summer. So it's really about understanding your particular context. I thought it would be useful to play this video. It's about Part L, so going a little bit deeper into some of the issues around fabric efficiency. It's one that we made alongside Zero Carbon Harrogate to help people understand how the building regulations relate to retrofit. So here goes.
Many homes have poor thermal performance. Drafty, poorly insulated homes leave those living in them cold, uncomfortable, and struggling with high energy bills and dangerous mould. Generating all this wasted energy has a big impact on our environment too. Whatever building work you do, from refurbishment to extensions to deep retrofit projects, your work can make an impact on the energy efficiency of people's homes. Part L of the building regulations provides guidance on energy efficiency. It covers the thermal performance of a building's fabric and heating systems. Part L requires heating systems to be designed to a maximum floor temperature of 55 degrees Celsius. This is to ensure that condensing gas boilers run efficiently and to help get homes ready for low carbon heating systems like heat pumps. The lower the floor temperature, the better, as heat pumps operate most efficiently at floor temperatures below 40 degrees Celsius. To meet the low floor temperature requirements, you will need to do heat loss calculations to choose appropriately sized radiators and pipework. You'll also need to consider how the heating system interacts with existing and planned fabric improvements. Part L provides target U values for the building fabric. These apply to both new and renovated elements of dwellings. New elements include the roof, external walls, and floor of an extension. Replacement windows and doors in an existing structure are also new elements. The new elements have lower, more demanding U-value targets than renovated elements. Renovated elements include the roof, external walls, and floor of an existing structure. If you are adding or replacing a layer on more than 50% of an external wall, roof, or floor, then the Part L targets apply. That means re-roofing, replastering, re-rendering, or reflooring are all regulated under Part L. These common building jobs are good opportunities to install appropriate insulation, and you may need to do so to meet the building regulations targets. Part L also has targets for improving the airtightness of buildings. These targets only apply to new builds, but for existing buildings there is guidance on measures you can do. Part L suggests sealing around surface penetrations when installing pipework and draft-proofing when installing windows. This can make a big difference to the thermal performance of a home. When you're doing airtightness work or installing insulation, it's important to take a risk-based approach. Considering risk and planning mitigations means that you can avoid introducing unexpected problems or causing damage. Moisture is a big risk in retrofit. It's covered in Part C. When you're insulating a suspended ground floor, high moisture levels in the subfloor can damage joists. The same goes for high moisture levels in the roof when installing a cold loft space. Ventilation is key to managing this moisture, and Part F has more on that. If you're insulating an external wall, you'll need to consider moisture too. Choose appropriate insulation approaches to avoid interstitial or surface condensation, as well as penetrating damp. The way that you install insulation also matters. Gaps between insulation materials and other elements can create thermal bridges. These gaps can also cause thermal bypass, where outside air gets between insulation layers or goes around the insulation altogether. These quality issues greatly reduce the efficiency of insulation and can cause damaging condensation and mold, so take care to ensure that insulation is properly installed and gaps are mitigated. There are other parts of building regulations that interact with Part L too. Part J covers air supply requirements for fuel-burning appliances. Part B covers fire safety, and Part O addresses overheating. Understanding the interactions between these different regulations helps you to manage risk when improving a building's energy efficiency. After assessing the risks, you may decide that meeting the Part L targets would cause problems. If meeting a target U value isn't technically or functionally feasible, you can have a higher U value, up to 0.7 watts per square metre Kelvin. And further exceptions apply, if necessary, to protect from the harmful effects of interstitial condensation, avoid excessive cost, or address heritage factors. Calculating the U value of each thermal element is one way of complying with Part L targets. If you're working on simple energy efficiency measures, like topping up loft insulation, this elemental approach is a good fit. But another approach is to model the performance of the whole building using SAP. By considering the whole building, you get greater design freedom and can trade off U values. That's useful when some elements underperform due to risk and context considerations. If you are working on a deep retrofit with multiple measures to consider, a modelled approach may work best. By considering interacting risks and implementing Part L's requirements, you can make a positive impact on people's homes and on our environment.
Hopefully that was useful. I think the other thing that we need to consider alongside insulation, which obviously Part L focuses on, it does mention air tightness or draft proofing. We'd always say that really key principle in addressing any energy efficiency retrofit project is that you should build tight. So that means make sure you've done as much as you can around draft proofing and air tightness, because insulation, ventilation and air tightness, they actually all go hand in hand. And again, going back to thinking about the building as a system, each of these helps the other perform better. So if you were to install insulation on new windows and not consider the air tightness at all, that would really quite badly negate a lot of the potential benefits of those works, because you end up with thermal bypass, or you end up with leaks around windows that reduce their impact, their positive impact. Good air tightness really can significantly improve comfort by eliminating drafts as well, because we tend to feel more uncomfortable because of drafts than we do because of just the general air temperature. It's the draft that helps cool you down, which can be a good thing in summer, but in the middle of winter isn't necessarily something that you want. And the other thing to note, which I think is maybe less well understood, is that good air tightness can really help improve the functioning of ventilation systems, because it helps to make sure that the air is flowing in the places that you want it to and which your ventilation strategy is designed it to, and not through cracks and gaps in the structure in an unplanned way that could lead to other risks, like increasing the risk of interstitial condensation. So yeah, alongside air tightness, so build tight, ventilate right. Any retrofit project that doesn't consider ventilation creates risks to the health of the building and its occupants. And I'd say, although obviously there is a lot of guidance around at what point planned ventilation might need to be introduced, I know from my experience and from various bits of research post-occupancy evaluation I've either read or been involved with, how leaky the building is doesn't actually bear a very direct relationship to the quality of the air within that building. So you can't rely on the fact that the building's leaky to say, oh, it doesn't matter, don't need a ventilation system or strategy of any kind because the building's just really leaky. Actually, just having a leaky building is no guarantee of good ventilation and no guarantee of good indoor air quality. So any retrofit plan really should include a ventilation assessment. So that's something that's set out in the PAS 2035 standard, and also a very robust ventilation strategy that includes considerations of moisture risks and maintenance and controls, and considers supply and extract and how that's all going to work together. It's really not just about sticking some fans in. I've got another short video that I will play you that's about part F that explains some of this in a bit more detail with some animations that hopefully will help.
Installing energy efficiency measures in a building stops heat from escaping and prevents cold air getting in, but it might also cause a building to become underventilated as air tightness increases. If this happens, the insulation and air tightness work can cause unintended problems with moisture and internal air quality. Part F of the building regulations covers ventilation. It applies to both new and existing buildings and helps you to ensure that there's enough fresh air to keep buildings safe and residents healthy. Part F can help you determine which ventilation strategy you need. You can confirm this by carrying out an air tightness test, which is outlined in Part L. But Part F also gives you another simplified method. This method can be used if ventilation is adequate. But if there are existing problems with condensation or mould, that is a sign that ventilation is inadequate and must be upgraded. If a building has adequate ventilation, Part F guides you to tally up all the energy efficiency works that have already been done to a building, plus all the works you are planning to install. By adding up all these works, you can determine if the planned energy efficiency improvements will leave the building in need of further ventilation. Take care. If you're not certain, it's always best to upgrade ventilation. Part F gives you 3 ventilation strategies to choose from. Natural ventilation strategies are simple to install, using background ventilators and intermittent extract ventilation in different places around the building. Then there are continuous ventilation systems, which can be decentralised or centralised. These systems aren't much more complicated to install than intermittent extract, though they do require ductwork. They can use passive intake methods, such as wall or window trickle vents, which means they can be easy to integrate into existing works and cause fewer drafts. Mechanical ventilation with heat recovery covers systems that continuously supply outdoor air to the inside of the building, whilst extracting indoor air to the outside over a heat exchanger. These systems can be complex to retrofit as they require considerable ductwork, but they have great potential for improving air quality and reducing energy use by recovering heat from the extract air. As well as these ventilation systems, Part F also details requirements for other forms of ventilation that need to be considered in the design of systems and choice of equipment. Purge ventilation refers to manually controlled ventilation of rooms to rapidly dilute pollutants or disperse water vapour. Mechanical options, like boost functions on fans, are one option for purge ventilation. Openings like windows and doors are another. In rooms where a lot of water vapour or pollutants are produced, dedicated ventilation is required. Kitchens, utility rooms, bathrooms and sanitary accommodation all require extract ventilation to maintain air quality. Part F allows for either intermittent or continuous extract ventilation and requires minimum extract rates to be met in these rooms. Finally, hall-dwelling ventilation is needed to remove any pollutants and water vapour that aren't removed by extract ventilation, purge ventilation or infiltration. It's also needed to supply fresh outdoor air into the building. Part F has targets for the rate of air supply to habitable rooms and gives guidance on undercuts indoors to make sure that air flows in and around the building. Once your installation work is done, Part F explains that you need to provide clear handover guidance to occupants on how to use their ventilation systems. This is really important to ensure that systems are used effectively and maintained to stay efficient. For more information about how the building regulations interact with retrofit, check out the links in the video description.
So, I hope that was useful. I think in summary, when we're thinking about approaches to retrofit and the principles that we need to keep in mind, I think the first and most important one is about being clear about your aims and the outcomes you're trying to achieve. So that's not considering a particular technology first or thinking just about add-ons. It's thinking about the whole thing and what it is you're actually trying to get out of it. And then applying the principles of responsible retrofit with those aims in mind. So that's about thinking about the whole house as a system and with a series of interacting parts and managing risks in that. Thinking about repairs, making sure that they're accounted for, balancing fabric works with the need for heat decarbonisation, thinking about what the need is in your particular project and what you can do within the constraints that you have. And then finally build type, so make sure that when you're doing these works, when you're going to all of the effort and expense of putting in new windows or insulating a floor, that you do as much as you can on the air tightness and draft proofing at the same time, so you get the full benefits of those works. And to make sure again that you're still providing a healthy indoor environment and you're not creating risks in the building fabric itself, that you ventilate right alongside that. So you have a planned ventilation strategy in retrofit, usually continuous ventilation of some form, to make sure that you're getting fresh air into the building and getting rid of pollutants. I hope that was useful. Might be just a bit of a useful refresh for some, but if there's anything else that you want to know, you can find out a bit more about us on the website there. All right, thanks very much. Thanks for listening.